Okay, you're supposed to evaluate this definite integral using partial fraction decomposition. I'm going to call this indefinite integral I for later on. Here's the original integrand, and the partial fraction decomposition says that for factors like this, you need a denominator for each possible exponent up to this value right here. So a over x plus b over x squared. This factor of the denominator is what we call an irreducible quadratic. And the numerator there has the form cx plus d, or whatever letters we're at by that time, over x squared plus 1. Now, if we multiply both sides of this equation by the LCD of all these denominators, which would be x squared times x squared plus 1, this denominator, of course, goes away, and we get a times the factors that remain from the LCD multiplier. X times x squared plus 1 plus b, the x squareds disappear, plus cx plus d times the factor x squared remains from the LCD. Now, here's a little trick you can do. If you can find out values of x that turn every term but one to a 0, you can isolate one of the a, b, c, or d's right away. And I can see that if I let x equal 0, this term and this term will become 0. If I put a 0 here, I get b times 1. And over here, if x is 0, I just get a 2. So right away, I've got one result. B is 2. Now it's necessary to equate coefficients. So we're going to distribute everything else, but I'm going to replace this b with a 2. So remove these parentheses, I get these two terms. Distribute the 2, I get 2x squared plus 2. Distribute the x squared, cx cubed plus dx squared. And now we equate coefficients. So this 4 right here has to be equal to the coefficients of the x cubed terms added together. Ax cubed plus cx cubed, a plus c has to equal 4. For this coefficient right here, the coefficient of x squared, looking over here, I see two terms with x squared, a 2 plus d. So 2 has to equal 2 plus d, which means d has to be equal to 0. And finally, this coefficient right here matched with this coefficient right here. That's the only term containing just the letter x, or the variable x. So a has to equal 3. If a is 3, put a 3 right here. C has to equal 1. D is 0. So there's your values. And that means I can be rewritten this way. A over x, 2 over x squared, plus, again, c is 1, d is 0. So this is x over x squared plus 1. I'm sure you know how to evaluate these antiderivatives term by term. There's your solution right there. Okay, and here's kind of proof on Desmos. There's the original function. I have g of x disabled, but if you go to the graph and enable it, you'll see that it matches f of x exactly. And here's our answer, big F, the antiderivative. If I take the derivative of that, I should get little f. And that's what this is right here. This black line also matches this red graph. And there you go. Hope that helped. If you have any questions, post a comment.